this lesson, we will learn about something called lithification, which is the process by which sediments combine to form sedimentary rocks. The term lithification is derived from the Greek language, and it might help you to remember the meaning of this term if you recall that the prefix lithos is Greek for rock. So we are really looking at the making of rock when we study lithification. There are two main ways that lithification occurs: compaction and cementation. We'll also touch on a third way that is important to some sediments called recrystallization. Compaction is the consolidation of sediments due to the intense pressing weight of overlying deposits. Compaction happens when sediments get buried. This literally squishes the sediment grains together, compressing them into a mass. With sufficient pressure and the passage of time, the grains get rearranged and more organized, much like winning a game of Tetris, where the majority of the falling tiles fit snugly together. As the sediments consolidate, the original pore space that divided them is reduced, and any water that was in those spaces is squeezed out. We see compaction happen with all sizes of sediment grains, but generally the larger sediments do not compact as successfully because their large grains are harder to fit together. However, finer grains of sediment, such as clay, tend to lithify better because these fine grains attract each other. For example, if you place a bowl full of grapes, which represents pebble-sized sediment grains, next to a bowl of flour, which represents clay-sized sediment grains, it's easy to see that compaction works better for smaller grained sediments. Another way lithification of sediments occurs is through cementation. Cementation is the process by which dissolved minerals crystallize and glue sediment grains together. This is an easy term to remember if you think of it like you would a bag of cement. A construction worker will take a bag of powdery cement and mix it with water to bind particles together. With cementation, we have minerals that grow and bind sediment together. The act of cementation is really what forms our sedimentary rocks. Compaction certainly helps the process along by bringing the individual grains close together. But even after compaction, there are spaces remaining between the grains. These spaces can be filled with water that contains dissolved ions. The ions get deposited and then crystallize, forming new minerals between the sediment grains. These minerals grow and glue the unconsolidated grains together into rock. We can also mention a third way lithification is accomplished, and that is through recrystallization. This is the process by which unstable minerals recrystallize into stable minerals, causing grains to bind together. As the name implies, there are already crystals formed, but these crystals may be unstable in a given chemical environment. These unstable crystals reform or recrystallize, and as they do, they grow and bind together, forming rock. This is a chemical process, and we tend to see this process at work in the formation of certain types of limestone and other chemical sedimentary rocks because their minerals can be less stable and therefore may change with shifts in the chemical environment.